Hi, good afternoon, everyone. Okay, so today we are going to study this chapter of chemical kinetics. Okay, so I hope this is your first class, right? For this chemical kinetics, new one. Because the new one, right? Like Gopi sir have some work to do, so that is why I'm taking your class this week. Okay, and today we are starting this chapter of chemical kinetics. Okay, so before continuing, so just let me tell you about myself. Okay, myself Lachu Naik. Okay, and I am from Odisha, and I am currently staying in Jenbi, Mysore. Okay, so for some days I am taking your this class. Okay, chemical kinetics. Okay, so I hope everyone is there and already it is 4:05. Okay, so we're supposed to start. Good afternoon, Sneha. So just, okay, let me check with this YouTube student also. Okay, I hope you go through this chapter. Okay, so for this basic idea, so that like if you once go through this one, then you can easily understand this chapter. This chemical kinetics, the simple chapter. Okay, like okay, in 10th or 11th class. Good evening, Anu. Okay, so like in 10th or 9th class, you have studied na, like how to find out speed of any car, okay, bike, if you are given distance, time. So this is all about this. You are given like what is the importance of this chapter, the importance like how to use those. So see one by one. So I hope everyone. So before that one, let's check a technical checkup whether if anybody have any issue. So I launched this poll. Please reply me here. Okay. So that so I hope everyone can see this problem. You just let me know. Okay, just I am not audible. Okay, so please check whether the problem is from my side or your side. Like previous class, it was nice. Even like there may be some issue. Okay, please try to like manage this one. If there is more issue, just let me know. If there is like more problem, ठीक ना? Otherwise, we are good to go. Okay, so let's start. So today we are going to discuss about the chemical kinetics. Okay, like if you are talking about chemistry, chemistry is all about changing new substance. Okay, chemical reaction means what? You're producing new substance. Okay, now so we know this what is chemical. So chemical is some substance, chemical reaction means some production of new substance. Okay, but here we are going to study kinetics of this chemical. Okay, so let's discuss what do you mean by chemical kinetics. Okay, so this kinetics, it is coming from a Greek word that is called kinesis. Okay, kinesis. And what do you mean by kinesis? Kinesis means movement. That means what? In this chapter, we are going to study about the movement of any particular reaction. Suppose there is changing from A to B. Here we are going to study how this changing taking place with respect to time. ठीक ना? So this thing today we are going to discuss. For example, let's take an example of this car. This car, like we have different type of vehicle which are running by petrol, diesel, CNG, and different type of fuel. Okay, so the question is why we are using different type of fuel? Like this some vehicle which are using the petrol, they don't use the diesel. So why these things? Like why they don't use? So these are the thing today we are we are going to discuss. Okay, so we know this like heavy vehicle, okay, like truck and other heavy vehicle, they're using diesel. So we can come to know diesel have higher that value, okay, high calorific value we can say. Okay, or in this chapter we are going to study the consumption rate. Like suppose there is a car which is using some fuel. So what is the rate at which, or what is the speed at which it consumes the fuel? Okay, like we know this, if you speed up the bike or car, it consumes more fuel. So why these things happen? Okay, so these are the things today we are going to discuss. Okay, so overall in this chapter we are discussing the speed of any reaction. Okay, speed of any reaction. So can you tell me what is this one? Like everyone thinking like what is this question? Everyone know this is a diamond. Okay, so this is a diamond. Okay, and can you tell me from where this diamond is made up of? Diamond, this is diamond. Okay, and everyone we know this diamond is made up of like from coal or graphite. Okay, so to convert coal into diamond, what is the time? Okay, correct, Jennifer, correct, carbon. Okay, so what is the time it will take to convert coal into diamond? Okay, like how it convert? We know this. It take plenty of time, like years, many years. Okay, and temperature is high temperature. We can say temperature up to like 15,000 Kelvin. Or if you're talking about pressure, it will take high pressure like 5 multiplied 10 to the 9 this much pressure. This is really huge pressure. Okay, so if you can provide this, you can convert carbon into diamond or graphite into diamond. Okay, so now in that case, if we convert this one graphite into diamond, then can we convert pencil? Like we know na, in our pencil we have this graphite. So can we convert that graphite into diamond so that we can tell, or we can be rich by overnight? Okay, or we can tell we have a diamond pencil, okay, which can cut even the hardest substance like glass. Okay, so can we do this one? Okay, so now tell me, can we convert the graphite which are using in the pencil into diamond? Can we do this? ठीक है, तो in that case एक दिन में पैसा डबल टाइप हो जाएगा. ठीक है, this thing. Okay, so now these are the things today we are going to discuss. Okay, so in this chapter we are going to discuss because okay, so whatever, okay, we know this carbon consists of this carbon or the graphite, it consists of carbon atom. Okay, and they have some distance between them. Okay, so if you are providing high pressure or high energy, okay, or high pressure, so it will bring this carbon together, like closer to each other, and the bond between them is strong. If their bond becomes strong, then we can say coal, which is a like that much strong substance, will convert into harder substance, because to bring those particle or atom closer to each other with high force of attraction, we need high temperature and high pressure. Okay, that is why we need all these things. Okay, so like nowadays we also heard of this artificial diamond. So in artificial diamond, what they are doing, they are providing this environment, high temperature and high pressure, so that they can easily convert graphite or carbon into diamond. So in this chapter, we are going to discuss about the factor which are responsible for particular change. Or here there is change of carbon into diamond, or we have different type of chemical reaction also. Okay, so if we come to know which are the factor affecting this particular conversion, so that according to our wish or desire, we can get the product by changing this factor. That is why we are studying this one. Okay, so that suppose we have a particular reaction which is taking place within 10 minutes. So that is up to us. If we come to know which are the factor affecting this particular reaction, that is up to us. Whether we can perform that chemical reaction with more than 10 minutes or less than 10 minutes by varying the factor like temperature, pressure, concentration, like that. So overall idea is, in this chapter we are discussing about those factors which are responsible for conversion of this, and what is the speed with which this conversion is taking place. Those are the things we will discuss in this chapter. Everyone understood this? Everyone, na? Or do you have any doubt? This is the basic idea, na? If you have any doubt, just let me know. But you can write in the chat. Na? Okay, then we are good to go. Okay. So chemical reaction. Okay. So for example, we have seen this one ki graphite or the coal is converted into diamond. So this is possible. So now tell me, can we convert plastic into diamond? Yes or no? Definitely no. Or if we do this one, then we can say that is plastic diamond, which is not possible. So feasibility means possibility. Possibility. And perhaps you will study in some chapter feasibility or possibility of reaction. We can understand, okay, by the gives free energy, and this we are studying in the chapter of thermodynamics. Okay, so for any reaction, if delta G value or gives free energy is less than 0, then we can say this particular reaction is possible. Okay, otherwise not. Like if you put petrol with fire, it will possible, like it will burn. If you put petrol with water, it will not proceed. So in that case, gives free energy is positive. So feasibility of any substance or any reaction or conversion will tell us the thermodynamics chapter. Okay. For example, I am taking this one. Okay, okay, simple this one so that you can easily understand. Na? So that is why I am taking this one, NH3. So how to balance this one? 2 nitrogen to put 2 here, 6 hydrogen, so put 3 here. Okay. So from by we are checking the delta G value, we find out delta G value is negative. Okay, so we can say this is feasibility, this reaction is possible. So if this reaction is possible, so can we tell like what is the extent, like what is the amount of this it can form? ये कितना form कर सकता है? Can we see this? Okay, we can find out the amount of NH3 it will give us by studying the chapter of equilibrium. So it will give, but it will give us the idea what is the amount of product it will give if you taken some amount of NH2 or H2. Now we can come to know what is the amount it can give us. Now the question is, can we find out the speed with which this nitrogen and hydrogen combine to give us ammonia? Yes, we can do by studying the chapter of chemical kinetics, which is this chapter. So in this chapter, we're going to discuss the speed of any particular reaction. Speed means what is the rate with which this reactant will consume themselves to give us the product. These are the things that we are going to discuss in this chapter. So everyone understood na importance of different chapter like thermodynamics, equilibrium, kinetics. Everyone understood this? Then shall we proceed? आपको समझ में आता है? You can just let me know ना. ठीक है. Okay. ठीक है. Let's proceed ना. See, this chapter is not too simple. Just listen to me carefully. Go through the book. Everything is okay. And solve some problem. Okay, so in this chapter, today we are going to discuss the rate of the reaction, factor affecting the rate of reaction, rate law, molecular rate. Tomorrow we will discuss this. Like next class, we will discuss these three. But today we will discuss these two things: rate of the reaction, factor affecting the rate of the reaction. Okay. So let's see one by one. Rate of the reaction means speed of the reaction. So, for example, this is our car. This is our car. So if we ask, this car is moving from one place to another. Suppose we have A here and B here. And suppose the distance between them is 20 kilometers. Okay. And it takes total 10 minutes to cover this one. If you are asked, what is the speed of this car? You can usually find out, right? Distance by time. So what we are doing, we take the change in position between A to B, which is 20, and the time between them, that is 10. If we do this one, we'll get the speed of this car. Similarly, if we want to find out the change of concentration of any reaction, what we are doing, we take, for example, this is our chemical reaction. So we want to find out what is the change or speed of this reaction. So how we will find out this one? So rate for this reaction is find out by taking the change in concentration. It has some initial value C1 and after some time it becomes C2 and time taken is T1 to T2. Okay, so how to find the rate of this chemical reaction? Just take the difference between concentration and difference between the time. You will get the rate of the chemical reaction. Take the simple one. Okay, and while we are find out this change of this chemical reaction, sometime we are taking the concentration term, okay, or sometime we are taking the pressure also, partial pressure. Like for example, we have a container in which we have some gases. After some time, its pressure will increase or decreasing. So how to find out change of this reaction? By taking the change in pressure by change in time. Okay, so that is why sometimes we are taking pressure also, partial pressure. In that time, the unit is atmospheric per second. And if you are taking the concentration, that is mole per liter per second. ठीक ना? Okay. I hope everyone understood this simple concept. Okay. It is like recap, like whatever the thing you have studied in junior class, like 10th and 9th or 11th, we are just recapping like that, this concept. Now let's see the rate of reaction. So now we will study rate means speed of the reaction. Okay, the speed may be different, na? Like if you are comparing the speed of this turtle with Usain Bolt, those are entirely different. Turtle, it is moving slowly. Usain Bolt is moving very fast, running very fast. Okay, so according to the speed, we have different type of reaction. So first one is reaction, moderate reaction. Moderate means it is between fast and slow. Okay, that is not like fast means what? It take too less time. Slow means what? It take large amount of time. Okay, like that. Okay, so let's discuss one by one with some example. Okay, with some example. So if you are taking any chemical reaction, so for example, we are taking HCl, okay, and NaOH. If we add them, instantly the chemical reaction is taking place and you will get the salt NaCl with water. Okay, so this is a fast reaction because it don't delay. If you add a HCl with NaOH, instantly it will give you the product. Okay, and what is indicator? Okay, what is indicator? Indicator means which indicate, like in bike or car we have indicate na, to indicate whether we are moving left or right. Like that, indicator indicates something. So this indicator will tell whether the particular reaction is taking place or not by changing its color. So it has some orange color here, and after that it changes into this color. So we can count to know reaction is took place. So indicator will indicate whether the particular reaction is take place or not. Okay, some ionic reaction also, they are fast reaction. Okay, and let's discuss. So why we are called this one is fast reaction? Because it don't delay. It take too less time to occur the reaction. That is why this is called fast reaction. Okay, and you can take example of acid-base reaction, they are fast reaction. After that, if you are talking about this one, decomposition of hydrogen peroxide, if you keep them this one, so it will not instantly give you the water and oxygen, but after some time it will give you water and hydrogen, because it don't take that much time or not instantly. That is why this is called moderate reaction. Moderate means it take little time, like 10-20 minutes, like that. Okay. And other example is inversion of cane sugar or hydrolysis of starch. Hydrolysis means starch means sugar only. We are adding water to that one. Like you have already discussed this thing in organic chemistry in haloarenes, haloalkane in this chapter. What is inversion of cane sugar and hydrolysis of starch? Okay, so these are some example. Just remember them. Okay. So now we have already discussed fast reaction, moderate reaction. So now let's see what is slow reaction. Okay, so now you can say this is just ring of that bike, sorry, not bike, car. Okay, this is just shiny one, new one. We can say it is shining. Okay, so if it is directly come contact with water and air, so after many years or many time it will corrode. So like you can see the difference between them. It is rough and it is smooth. It is shining, it is not. Though it will become rust. ठीक ना? So because this particular reaction or this changes take place large amount of time, like years, okay, or large amount of time we can say, okay, months or years. That is why this is called slow process. Sorry, slow reaction, because it take large time. Okay, and the reaction is too small. Okay. So an example, like we have already discussed, the conversion of graphite into diamond or a string of iron. These are some slow reactions. Like you can think of other reaction also, which are fast, moderate, okay, and slow reaction. You can write one or two in the chart also, okay, so that we can discuss. So I hope everyone understood this type of reaction according to their speed. Those are three: fast, moderate, slow. Okay. Okay, so let's proceed. So, for any particular reaction, something is converted into something. I mean, some substance is converted into some product. So the initial substance are taking reactant, and the thing will get is product. Okay, so let's consider this one. So R is converted to product. Okay. So in this, we can tell if this reaction is taking place, so whatever the concentration of R, it will reduce, and the concentration of P will increase. Okay. So we can say rate of disappearance of R is decreasing the concentration of R with time taken. Like initially it has some value, after some time it has some value. So the whatever the change in concentration of R with respect to time, that is called rate of disappearance of R. And why we're taking minus sign here? We're taking minus sign here. So this minus sign indicate there is reduction in concentration of R. Okay, that is why we're taking minus sign. And if we want to write the production rate or appearance of P, then how we can write? Then we can write rate of appearance of P can be written increase in the concentration of P and total time. So why we put plus sign here? This plus sign indicate there is increasing in the concentration of P. Okay, that is why we put plus sign here. So this simply, okay, like where you're writing na speed of car, speed of bike, how you're writing total distance or total time. This also total change by total time. For reactant, put the minus sign. For product, put the plus sign. Minus and why minus sign? Because concentration is decreasing. Why plus sign? Because concentration is increasing. Simple. Okay. After that, let's proceed. Okay. Like if we are seeing for any reaction, like if you are taking time T1 and T2, and we try to see the value of reactant and product, then we can come to know this green color is our reactant. Okay. So at T1, value is R1. Okay. And T2, you can see its value is R2. If you compare the value of R1 and R2, then you can find out R2 is less than R1. That means what? With passage of time, value of concentration of R, it is reducing. Okay. And for the product, it will increasing. At T1, its value is P1 and T2's value is P2. So you can compare P1 and P2, its value is increasing. Its value is increasing. That is why we are writing like this. Okay. So this is the rate of change of R and P. Okay, so we have seen the diagram also. I hope you understood this. Do you have any doubt here or we are good to go? आगे बढ़े फिर ठीक है तो हम आगे बढ़ते हैं ना. Okay, now let's discuss the instantaneous rate or average rate. Okay, like we have now come to know, we are discussing about the speed. Speed are two types. One is average, another one is instantaneous. Okay, like this name suggests instantaneous. Instantaneous means what? At exact that particular time. Okay, so what do you mean by this one? Suppose it's our car. Okay, and this car is moving from A to B. A to B by passing this point C. So let's take distance of this one. This is suppose 0 kilometer. Okay, to this one is 10 kilometer. So initial time is T1 and final time is T2. And when the car reached C, the time was T3. Okay, like that. So if they ask you what is the average speed? So how we are find out? I denote the speed with V, the average equal to what is the total distance it covered? Total distance is 10 minus 0, this is 10 kilometer. Okay. What is the time? Time is T2 minus T1. So let's assume it's take total 10 minutes. 10 minutes. Okay, so just put 10 kilometer per 10 minute. So this is 1 kilometer per minute. You can count this kilometer into meter, centimeter, minute into hour, second, this is up to you. Okay, according to our requirement, we can change that unit. Okay, so you don't worry about that. So this is the average. Average means what is the total change of distance with total time, and what is the instantaneous. Instantaneous means, suppose they ask you what is the velocity of this car when the time is t3, or what is the velocity of car at the point of C. Because that exact, they ask you the speed of that car exactly some particular time, a particular point. That is why this is called instant velocity. So suppose at this one, its velocity is, for example, 0.8 kilometer per minute, for example. So we can say instant velocity of this car at point C equal to 0.8 kilometer per minute. Okay, now we are going to see how to find out average velocity or instantaneous velocity. Okay, don't worry, but I hope you understood like what is the overall idea of average velocity and instantaneous velocity. So this is all about the car, and now we can use the same concept or logic for the consumption for any particular reaction. Okay, so I hope you understood this. समझ में है ना सभी को ये, or do you have any doubt? ठीक है, so like you don't have any doubt. ठीक, if you have any doubt ना, आप मुझे you can write in the chat or just tell me, we can discuss ना. Okay. So average rate of the reaction is the rate of the reaction measured in the certain interval of time. मतलब कुछ particular interval time में कितना changes हुआ, that is the rate of the reaction. ठीक है, and it will be denoted by like, consider we have reaction R is converted into P. So average can be written total change in the concentration of R and the total time taken to occur in this change. Okay, and if you're like change in R by T, why you know now why we put this minus sign here, because concentration is decreasing, so that is why we're putting minus sign here. And always write the change final minus initial, not initial minus final. Okay, always write final minus initial, and we are putting this respective value. Okay, and we got this here. So average will get this. Okay, so if you are taking this graph, okay, this is for product, average rate of product, this average rate of reactant, and we have already discussed them. But here we just put those value at T2 time, value of concentration product is P2 and T1 is P1 like that, and we have put the value. Okay, so this is the average. Average means simple, for particular interval what is the change. And if you are talking about instantaneous, instantaneous means at particular time, or we can say, okay, while we are finding the average, suppose the question is what is the average change in, what is the average speed if the time we are taking from 40 minutes to 60 minutes. So we are taking this interval, in this interval, what is the change of the distance. Okay, but instantaneous means what? We are reducing this interval. ये जहाँ से 40 से 60 था ना, it have 20 difference. What will do? We are reducing this 20 to a particular point. जैसे we are considering this particular point T1. So what is the speed of this car or this reaction at time equal to T1, or let's assume here 50 minutes. So what is the speed of the reaction or rate of the reaction at time equal to T1 or 50 minutes? Okay. So I will find out this one. We find out this by drawing the tangent. Okay. So like draw a line and it will touch this curve at particular point, and from there draw the curve. And this line or tangent, slope of the tangent will give you the instantaneous rate of product and reactant. Take its slope. Slope means tan theta for this one. This will it will give you the rate of the reaction, instantaneous one. Okay, na? So in this case, you need not take the interval, okay, but at particular that time, what is the change? Okay. I hope everyone understood this, like how to find out average rate or instantaneous rate by using the graph, or like same like directly without graph also. Okay. So it become more clarify if we using like if you're seeing some numerical. Okay, so everyone please try to solve this. So I will give you idea how to solve this one, but at least try or read the question and try to understand like how to solve this type of problem. So whenever you are solving any numerical, the first thing is you have to write down the data, so that by looking at the data, you can you can have some idea like how to proceed, which are the formula you are using, because now you're studying different type of formula and you don't know how to use which formula. So first write down the data so that you can have idea like which formula you have to use. Okay, so let me read the question for you. For a reaction concentration of product in given AJ C equal to 2.5 T square minus 4 mole per liter, find average rate of reaction between the time interval T equal to 10 second and T equal to 20 second. Also find out instantaneous rate of reaction at T equal to 12. Okay, so here we have to find out average rate, and another one is instantaneous. We know this. For average we have to take change. Okay, so let's take it T1 concentration become C1 by putting value this one. So we can put 2.5 and value equal to 10 whole square minus 4. Okay. After that at T equal to 20, so put the value of T equal to this much, 2.5 20 whole square. Okay, minus 4. So you'll get some value here. Okay, and the total change in time equal to T2 minus T1, that is 20 minus 10 equal to 10. So to find out the average, what we will do, this is simple one. Okay, so C2 minus C1 by total time, this is 10, because this is our reactant. So put minus n here. Minus n here, you will get the answer. This is simple one. Just the thing is you need to solve this. Okay. And how to find out instantaneous? Instantaneous we know na, you have to differentiate this. So instantaneous is dc by dt at time equal to 12 seconds. So what we will do? Differentiate 2.5 t square minus 4 with time. Okay, with time. So if we differentiate this one, we will get 2.5 multiply 2t equal to, you will get this one equal to 5t. 5t, t equal to, we are taking 12, so this is equal to 60 mole per liter, time is second per second. This is instantaneous. Average you can easily find out. So find the value of concentration of at t equal to 10 second, 20 second, take the difference of time, you'll get the average. Average is simple. Instantaneous, I thought there is some difficulty, so I solved this. Okay, na? This one, this much will get instantaneous. So at exactly 12 seconds, its rate or its speed is 60 mole per liter per second. Itna speed se badlega. Okay. I hope you understood this numerical, everyone. Or do you have any doubt? Shall I repeat this or it is understood, everyone? Okay, so let's proceed. I hope you understood this one. So if you have any doubt, just you can write in the chat or you can ask me directly. ठीक हम आगे बढ़ते चलो. Okay, this one. Expression of rate for reaction. Okay, so इसका मतलब क्या है? What is the expression for rate of the reaction? So we have some reaction. Okay, and we come to know how to find out the speed of this reaction. Now, suppose you are given different reactant. Suppose you are in this reaction, we are using nitrogen, hydrogen, and give us ammonia. It gives us ammonia. Okay, so because here you can see whatever the number of reactant you are taking, those are not same. इसका मतलब ये होता है कि whatever the consumption rate or production rate, they are different. Like you can see, when there is consumption of 1 mole of nitrogen, it will consume 3 mole of hydrogen, and it will give us 2 mole of ammonia. So how to relate each of these, like rate of change of each of these, like rate of change of nitrogen with rate of change of hydrogen with rate of change of ammonia, how to relate them. Okay, so let's see one by one. So let's take they are changing because 1 minute na. So we can say 1 mole of nitrogen is consumed in 1 minute. Why we put minus sign here? because it's a reactant, that is why we put the minus sign. Hydrogen also minus, so we put this rate of change of hydrogen with respect to time. We're taking time equal to 1 minute, so here we can say 3 mole of hydrogen is consumed with 1 minute. And here we can say 2 mole of ammonia is produced within 1 minute, because this is the rate. Or we can say hydrogen, or suppose speed of this particular reaction, speed with which this changing is taking place. So we can say suppose this speed, or we can say change of nitrogen with time is suppose 1x, speed, suppose x is our speed. So here we can say speed of change of hydrogen is 3x, because 3 mole are changing per minute. So let's take this 3x, speed is 3x. And here 2 mole is producing, so let's take the speed is 2x. If you relate them, then we can say this consumption rate of nitrogen is 1x. Like suppose speed is x, if we relate with hydrogen, then we'll get this is 3x speed. This x is speed, and ammonia production rate is 2x. With 2x speed is producing. So if we want to relate it is speed, or we can say speed is x, speed of the reaction with each of these, then we can write, for here we can write x equal to this much dn 2 by dt. Okay, here we can write speed or x equal to 1 by 3 change in hydrogen by change in time, and here we can write x equal to change in NH3 by change in time. Now if you equate all the rate or speed, then we can get rate of change of N2 is equal to 1 by 3 rate of change of hydrogen equal to 1 by 2 rate of change of nitrogen, sorry ammonia. ओके, तो देखो इफ वी टेक दिस रिलेशन, अगर इस रिलेशन को तुम लेते हो, सो इससे तुम्हें ये पता चलता है सपोज NO2 इज चेंजिंग विद सम स्पीड, कुछ स्पीड से चेंज हो रहा है, उसका अगर 3 टाइम लेते हो ना, 3 टाइम, इफ यू टेक 3 टाइम ऑफ रेट ऑफ चेंज ऑफ नाइट्रोजन, देन दैट इज द स्पीड ऑफ रेट ऑफ चेंज ऑफ हाइड्रोजन. ठीक है, और वी कैन से if you divide the speed of rate of change of hydrogen by 3, then that speed is equal to speed of nitrogen change. ठीक है, and this overall if you relate them this, then you will get overall rate of the reaction, rate of reaction. ठीक है, मतलब जो रिएक्शन का जितना स्पीड होगा ना, जितना स्पीड होगा, we can relate speed of each, like nitrogen, hydrogen and NH3. Okay, this one. So for different reaction we can write this relation. Everyone understood ना how we write this? इसको हमने कैसे लिखा? Everyone understood this? Okay. So let's check whether you understood this or not. उसके लिए हम थोड़ा सा क्वेश्चन लेते हैं, थोड़ा सा नहीं पूरा सा ही लेंगे, लेकिन you will solve this ना. Okay. So I've already written for this one. Like suppose we have, let's generalize for any chemical reaction. Or suppose this is our reaction A mole of A react with B mole of B, which will give us C mole of C and D mole of D. So if we want to write rate of change of A, rate of reaction with respect to A, मतलब A के हिसाब से what is the speed of the reaction, then we can write rate of disappearance of A dA by dt divided by A. अच्छा, once more. Here I am explaining. Okay, see here. So here we can say when a mole of A is consuming, a mole of जितना कंज्यूम, अच्छा ठीक है, प्रीवियस लेता हूँ, I'm taking the previous one. Well, let me erase everything. Okay, here, like here you can see ना, this is the point. 3 mole, when there is consumption of 3 mole of hydrogen, at that time only 1 mole is consumed. That means what? Consumption rate of hydrogen is more than the nitrogen. मतलब this reaction have some speed. If we compare that speed with nitrogen and hydrogen, then we can see consumption rate of hydrogen is more than consumption rate of nitrogen. ठीक है, तो हम ऐसा बोल सकते हैं नाइट्रोजन का जितना स्पीड होगा ना, उसमें if you multiply 3 times, then that is the speed of hydrogen, because ये ऐसा कंज्यूम हो रहा है. Okay, टू रिलेट दिस वन, टू इक्वेट दिस वन, जैसे होता है ना कि 3 मोल ऑफ हाइड्रोजन कंज्यूमिंग एट दैट टाइम 1 मोल ऑफ नाइट्रोजन कंज्यूमिंग. Okay, so if we try to find out ki what is the relation between their speed, so we can come to know speed of this hydrogen divided by 3 equal to the speed of nitrogen. Okay, everyone understood na? ये समझ में है ना कि how we got 1/3. Okay, because its speed is more 3 times with respect to this one. Okay, to equate their speed we have to balance them, like we have to divide them. ठीक है, तो यहां से हमें पता चलता है कि वॉट एवर द कंजम्पशन रेट ऑफ हाइड्रोजन इफ वी डिवाइड विथ 3 देन दैट इज इक्वल टू द स्पीड ऑफ नाइट्रोजन. ठीक है, और इसका दोनों का भी सेम है, लाइक सेम लॉजिक वी कैन पुट फॉर एमोनिया आल्सो. ठीक है, उसका जो स्पीड है ना, टू इक्वेट दैट स्पीड ऑफ द रिएक्शन वी आर डिवाइडिंग देयर कोएफिशिएंट विथ ईच स्पीड. जैसे हाइड्रोजन कंजम्पशन रेट ऑफ हाइड्रोजन हैव सम स्पीड, ठीक है, and consumption of ammonia has some speed. If you divide their speed with their coefficient, then you will get rate of the reaction. जो reaction का जो speed होगा ना, you will get that one, rate of the reaction. So rate of the reaction can be relate with each term, each reactant product. इसीलिए we are dividing the coefficient. ठीक है, otherwise we could have multiply. समझ में? Everyone understood ना? जैसे मान लो कि we have A and B. It can eat 1 sweet. एक बार में 1 स्वीट खा सकता है. It can eat 3 sweet. 3 sweet. ठीक है. तो if you're comparing their speed, then we can say whatever the speed of A, it's 3 times speed of B. तो उसको हम कैसे लिखेंगे? by 3 करके लिखेंगे ना. That is why. ठीक है. Okay. Everyone understood this. थोड़ा सा there may be some confusion, but logically सोचो you can get the answer. ठीक है, so like simple है ना. now you everyone you understood this. just to rate the speed of the reaction or rate of the reaction, just take the rate of each term like A, B, C, D divided by each coefficient, then you will get the answer. Or why we put minus sign here? Because the reactant its constants will reduce, so we put minus sign. Why we put the plus here? Because जो product है its value constants are increasing, so we put plus sign there. Take simple logic. I hope you understood this. चलो इसका लिखो तो फर्स्ट वन. ट्राई दिस वन, आई विल डिस्कस, बट प्लीज ट्राई कि हाउ वी कैन राइट रेट. तो इसका जो व्हाट एवर द रेट ऑफ दिस रिएक्शन, हाउ वी कैन राइट रेट ऑफ द रिएक्शन विथ रेस्पेक्ट टू मर्क्यूरी, क्लोरीन एंड HgCl2. Okay, so let's see, like we can write rate of this reaction equal to, तो if we want to write rate of the reaction with respect to mercury, तो हम कैसे लिखेंगे? rate of change of mercury equal to rate change of chlorine, because they have coefficient 1. आगे 1 है ना, so divided by 1. This equal to this. So why minus? Because those are reactant concentration is decreasing. So this is simple one. Coefficient is 1, so कोई दिक्कत ही नहीं हुआ. Okay. Now what is the way of writing this if we have some different coefficients? So here we are how we are writing this one. Rate of the reaction is for this one, rate of change of hydrogen iodide by 2 equal to rate of change of hydrogen equal to rate of change of iodine. Everyone understood na how we write things? Simple है, like to relate this with rate of the reaction, write their change with respect to time and divided by the coefficient, whatever the coefficient you are taking. Simple है, मतलब उतना भी लॉजिक नहीं लगाना है. Everyone understood ना this one? कोई तो सोच रहे तो फिर इसको पढ़ के क्या फायदा, इतना इजी है. विल मेक इट कॉम्प्लेक्स, डोंट वरी. ठीक है, because to understand the complex thing we need to understand the simple thing first. ठीक है, अब रेडी हो जाओ टेस्ट, मतलब टेस्ट के लिए नहीं, द कॉन्सेप्ट टेस्ट ना. ट्राई टू सॉल्व दिस वन. यू कैन आंसर मी इन द चार्ट और बोल भी सकते हो. ट्राई करो इसको. इफ यू सॉल्व दिस वन ना, so ये like I assume कि everyone you understood this logic. The question is 3 mole of A converted into 2 mole of B. What is the rate of reaction dB by dt with respect to A? Rate of change of A. Try करो तो इसको everyone. Okay, so let's solve this one. Simple. Okay, so whenever you are asked this type of question, so first you have to write the expression of this rate. So we have 3 mole of A. So how we can write the rate? Rate can be written R. I will take the other one. Green. Rate equal to, we have A is our reactant, so minus coefficient is 3, so 1 by 3 rate of change of A with T equal to 1 by 2 rate of change of B with T. This is the simple relation. अभी हमें क्या पूछा है? We need to get the value of this one. So we can write rate of change of B with respect to time equal to, take to that side 2 by 3 minus dB, dA by dt. So which is the answer? B na? B is the answer. Everyone understood na how we solve this? Everyone, simple and sweet hai na concept. Okay. I hope everyone you understood this. ठीक, simple है, just write the rate अब like relation between them and rearrange according to the term you want. ठीक है, अभी let's proceed. अभी तो खत्म हो गया. Everyone try to solve this. इसको try करो एक बार. After that I will solve. देखो, attempt करना important है. Answer तो आता जाता रहता है. ऐसा नहीं मतलब you need to get the correct answer also. But if you try ना, even though you not get answer for this question, but for other question you can definitely get that one. ठीक है, you once try this. After that I will solving this. अभी एक बार try करो. So whenever you are solving numerical ना, write down all the data first, so that by looking at this data you can think which type of formula you need to use. ठीक है, वो idea हो जाता है. नहीं तो you have studied ना plenty of formula, plenty of equation, reaction. So how to know which one you have to use? For that you need to write the data. ठीक, देखो. So let me read the question. In a reaction to A gives product, the concentration of A decreased from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Calculate rate of reaction. इतना आएगा क्या? थोड़ा सा अलग आएगा मेरे हिसाब से. देखते हैं, सोल्व करेंगे. The main thing is attempt, वो अच्छा है, जेन्यू करता, ठीक है. Calculate the rate of reaction during this interval. Okay, so let's solve this. ठीक है, हम चलो इसको सोल्व करते हैं. शायद आपने उसको छोड़ दिया. Here you are given 2A, not A. शायद you mistaken that one. So let's see. So how to write the rate of the reaction? So rate of the reaction, because we are given 2A, is converted into some product. So we can write rate equal to 1 by 2 dA by dt. ठीक है, minus n here, minus n here. So this A value changing from 0.5 to 0.4. So change can be written final minus initial divided by 2 multiply time is 10. ठीक है, so you will get, and minus sign is here. ठीक है ना, so you will get 0.1 by 20, or we can say 1 by 200, or multiply divided by 5, so we will get 5 by 1000. This can be written 5 multiply 10 to the power minus 3. The unit is mole per liter per minute. Everyone understood how you solve this? Because they ask us the rate of the reaction, not the rate of change of A. आप शायद इसमें mistake कर गए. Not the rate of change of A, but they ask us rate of the reaction. Reaction पूछा है, not the rate of change of A. So what we are doing to get the rate of change of the reaction, we use the value of rate of change of A. ठीक है, and by using the relation we got this. Everyone understood ना? सभी को समझ में आया, और do you have any doubt? I hope you understood this. ठीक है, इसको एक बार सही से देख लेना बाद में, और अभी भी है तो you can take the screenshot. Okay. वही वही आंसर है, मतलब अगर रिटेन है उसमें। सो यू विल सॉल्व दिस लेटर, ये नेक्स्ट के लिए इसमें आंसर भी है, तो मैं जल्दी से पार कर देता हूँ। यू विल सॉल्व दिस, ये होमवर्क है, ठीक है ना। सो हमने क्या क्या पढ़ा? सो वी हैव स्टडी द rate of difference of reactant product, and how to write rate with respect to reactant with respect to product. Here we are dividing the coefficient, like that we have study. And here we also study the importance of chapter, okay, and the speed of the reaction or rate of the reaction. Rate of the reaction are two types. One is average rate, one other one is instantaneous rate. And if you're talking about the type of reaction in the term of speed or rate, we have three types: slow, moderate, fast, and we have also discussing some example. So ये simple सा कुछ चीजें we have discussed in this chapter, ठीक है। So next we'll go with rate law, molecularity, ठीक है, and rate constant, everything, okay. So I hope everyone understood this, okay. So जानने के लिए देखिए अगला एपिसोड, ठीक है। आज का यही खत्म होता है। Do you have any doubt? अभी इसमें किसी को कुछ डाउट है, just let me know, we can discuss, otherwise you can leave the class. thumbs up करके you can leave the class. Okay, thank you everyone, thank you, ठीक है। just go through this chapter and solve some question and get back to the next class so that you can easily understand the concept, ठीक है। चलो फिर हम मिलते हैं कभी। thank you everyone, thank you Susri, thank you Janvi for that. okay. ठीक है, फिर चलो, you are attend in the next class, I am leaving, ठीक है ना। thank you everyone.